So welcome everyone. I am here to represent fifth group. Our group members are myself Adarsh, Avaneesh, Anurag and Abhinav. So the topic that was given to us was to write a program to implement 4-bit 5-bit block coding. The program should read 4-bit data word from the user and then converts it into a 5-bit code word at the senders. After transmission of the code word, the receiver should convert the 4-bit code word back to the data word if the receiver code word is valid. Otherwise, it should detect error and discard the packet. So we have approached this problem through C++. So let me show you how it works. But before that, we have to know what is this block coding. So in general, block coding changes a block of m bits into a block of n bits, where n is larger than m. So in block coding, normally it has three steps: division, substitution, and combination. In the division step, a sequence of bits is divided into group of m bits. Like for example, we are doing 4-bit, 5-bit. In it, the original bit sequence is divided into 4-bit groups. At the heart of the block coding is the substitution step. In this step, we substitute an m-bit group with an n-bit group. For example, in 4-bit, 5-bit encoding, we substitute a 4-bit group with a 5-bit group. Finally, the n-bit groups are combined to form a stream. Okay. So actually in 4-bit, 5-bit coding scheme, it was designed to be used in combination with NRZ-I. So as we can recall that NRZ-I has a good signal rate, which is 1/2 of that of the biphase. But it has a synchronization problem. But for that we have a solution. Like one solution is that to change the bit stream prior to the encoding with NRZ-I. And then at the receiver, the NRZ-I encoded digital signal is first decoded into a stream of bits and then again remove the redundancy. So now we'll see how the code is working. So as you can see, the first line of the code represents all the header files, iostream, ctime and cstdlib. Actually this time and stdlib, as you know, it's C libraries, but to use it in C++, we have to write that C letter in front of them. So our first function is print random. What it does is that it simply returns a random number from 0 to 32. That's how simple it is. Now why 0 to 32? Because to convert 4-bit to 5-bit, we have to map what it means that we have to map the numbers from 0 to 16 to 0 to 32, because 5-bit means 2 raised to a 5, that is 32. Okay, so that is how it works. So our second function is the binary to decimal function. As it is named, it simply takes a binary number as input and converts it into its decimal form. And here you can use some built-in functions also to implement this. The same it also does this decimal to binary also. It takes a decimal number as input and then converts it into a binary number. Its binary number. Now the main function. Now I'm going to explain you guys how this algorithm works from here. Okay. See, first we'll take an input from the user, which will be a 4-bit binary number. Now here the variable number is used to take that value, and then we'll convert it into a 5-bit. Okay, so we have taken a number here. You can say you can see that enter the 4-bit binary data word and sin number. So we have inputted the number and we have to convert it into a 5-bit. So where we have converted it into 5-bit is that here. We simply use as a random function which maps that 4-bit to a 5-bit. Okay, this print random does that. Now second, we'll take a code word and then transmit it to the receiver, where it will be checked by our previously mapped data word, like you can see here. See, we'll take a code word, int code word, and we take any random code word. Okay. And then what we'll do is that we'll send it to the receiver. Now, at the receiver end, we have already mapped 4-bit data that we have got from the user. Where we have mapped it, like see here, that the number that we have got from the user data number, we have converted in, it is in binary, so we have converted it into decimal, and this variable holds that value data word. Okay, and here we have encoded it into 5-bit. As you can see, we have initialized one value dw equals to 0, and it simply means data word, dw means data word. It only takes that value, the 5-bit. So we have used some methods. If the number data word is 0, then simply call that dw, map it to 30, or if it is 1, then take it as 9. If it is 2 or 3, then then check that it is even or not. If it's even, then take it as 20, otherwise as 21. And again, it's simply a series of checking, and simply we have applied some rules, encryption rules, to map it to 4-bit to 5-bit. Okay, now as we have completed this, I've said, in second step we'll take a code word and transmit it to the receiver, where it will be checked by a previously mapped data word, like what we have mapped here. You can see all these if, else if, all these things. Okay, and then now if the code word matches if the code word that we have got matches with the data word, like see here, we have checked whether the code word matches with the data word. If it matches, then we'll display valid. Okay, and we have also shown the binary version of that word, and we'll simply print valid. If not, then we'll simply discard that word and print not valid. Got it? See here, we have taken the code word. The normal code word that we have taken is simply random, which is generated from this random function, as you can see here. Yeah, so let me show you all the output of this. See, this is the output. At the sender's end, we have entered a 4-bit binary data word. The user has entered this 0011, which is 3, and we have encoded it into this 1111 and then 0. Okay, I've read it from backside. And then it is sent to the receiver, and at the receiver end, that code word is not valid, because what we have encoded, that code word, that this 0011, what we have mapped it as this 10101. So this 0011 is mapped to this 10101. So this 4-bit is mapped with this 5-bit, not with this 0 and this followed by 4 ones. So that's why it is showing not valid. So we'll take another example. Again, the user has entered 1001 and it is encoded as 10011, and at the receiver end, see, it is not valid, because what we have encoded, what the code word is sent is simply matches with the mapped word code. Okay, so that's why it is printing valid. So thank you all. Have a nice day.